In this video, I will talk about factoring special forms. That includes perfect squares as well as sums, differences of squares and cubes. So before we begin doing some factoring, let's get some practice multiplying and simplifying. Basically, distributing. So, in our first question, we have a plus b times a plus b. So, if I multiply a times a, I will get a squared. If I multiply a times b, I will get ab. If I multiply b times a, I will also get ab. And if I multiply b times b, I will get b squared. So, combining our like terms, we find our final answer is a squared plus 2ab plus b squared. What if I have something like this one? Well, really, a plus b, the whole thing squared, is going to be a plus b times a plus b, because squaring means you multiply by itself. So I now see, oh hey, something that looks like this is really this problem we did over here. And I will get as my answer a squared plus 2ab plus b squared. What about if one of them is positive and the other is negative? Then a times a gets me a squared. A times minus b gets me minus ab. B times a gets me plus ab. And b times minus b gets me minus b squared. Now I see that this minus ab plus ab cancel each other out. So I get just a squared minus b squared. Let's do it again. A minus b squared is really a minus b times a minus b. A times a will get me a squared. A times negative b will get me minus ab. Negative b times a will get me another minus ab. And negative times negative gets me positive. So negative b times negative b is positive b squared. Combining like terms again, I find that these middle terms add up to negative 2ab, and I have my final answer. What about these crazy looking ones at the bottom? I'm going to do it the same way. A times a squared will get me to a to the third. A times minus ab will be minus a squared b. A times b squared will give me plus ab squared. B times a squared will get me plus a squared b. B times minus ab will get me minus ab squared. And b times b squared will get me to b cubed. Now, if I combine like terms, I have only one a cubed. This a squared b term cancels with the other because one is positive, one is negative. And the same thing happens with the ab squared terms. They also cancel. And I'll be left with just a cubed plus b cubed. Let's try it again. A times a squared is a cubed. A times ab will get me plus a squared b. A times b squared will get me plus ab squared. negative b times a squared will get me minus a squared b. Negative b times ab will get me minus ab squared. And negative b times positive b squared will get me minus b to the third. Again, these terms here cancel. And I'm left with just a cubed minus b cubed. So this is actually all we need to know for our special forms. So a perfect square trinomial is one that gives you a perfect square as your answer, which means that after factoring, your answer will either be something plus something else squared, or it will be something minus something else squared. And if we look back at our work, a plus b, when we square it, got us a squared plus 2ab plus b squared. And a minus b squared got me a squared minus 2ab plus b squared. So I can put those as what it would look like before factoring. Now, let's look at some of these other ones. So I'm going to skip sum of squares for a moment and go to difference of squares. Difference means I'm subtracting perfect squares. So if I look back at my work, there is one where I'm subtracting perfect squares. So that's what it looks like beforehand. This is what it's going to look like after I factor. So difference of squares is going to be a squared minus b squared. And when I factor, it will be a plus b, a minus b. Now, if that's the difference of squares, the sum of squares will look like a squared plus b squared. Sum of cubes, a cubed plus b cubed. Difference of cubes, a cubed minus b cubed. So let's see if we can find any of the rest of these. Well, here's our sum of cubes and our difference of cubes. So I can go back and copy what it came from as our factorization. Now, what about this sum of squares? I didn't get a sum of squares as any of my answers here. And if I think about, well, what could a squared plus b squared have come from? Well, to get to a squared at the beginning, I would have to have an a and an a. To get to b squared at the end, I would have to have a b and a b. So the question now is, what signs would go in here? Well, if they're both positive, then I get this. That's not a squared plus b squared. If they're both negative, that's not going to work. If one is positive, one is negative, that gives us the minus, right? So this is not going to work. And in general, every single time you see a sum of squares, you can immediately conclude that you cannot factor it. So just like a number that cannot be factored is called prime, A polynomial that cannot be factored is called a prime. And so these are all of our special forms that whenever you see them, you can immediately jump to these factored answers.